आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. In this podcast, we welcome Dr. Ashis Kumar Chakraborty, who is a senior technical officer at the Indian Statistical Institute, Kolkata. Sir shares his vast experience and knowledge in his area of research in this podcast.
I have started my journey into academics in ISI itself as a BStat student way back in 1975, and I'm still with ISI. So probably the association is almost 49 years now. In between, I have, after passing out BStat and MStat from ISI, I have done my PhD from Indian Institute of Science, Bangalore. And that PhD topic was software reliability. So even though I am right now working on data analytics and software reliability and a couple of other things, but today I will be mostly talking about software reliability. So software reliability, the term is a little bit ambiguous in the sense that what normally we find in any sophisticated device is that there is a hardware part, there is a software part. Now, hardware reliability has been studied for a long time and people have established lots of ways of finding out the reliability of hardware. Whereas the software, particularly, it took almost quite a few decades for people to understand that software has a uncertain behavior in nature. That's maybe because the software by itself is something which is quite different from hardware, because hardware we can see, we can touch. If it fails, we can find out what is the problem. Whereas software, there are some peculiarities. One is that it cannot be seen, it cannot be touched. So it becomes a difficult object, but it works. And so when people started thinking, initially people were thinking about that a program in those days, for example, when we were students, it was basically a program. Software term probably did not come at that time. So a program, when we used to write, we used to test the program, find out whether there is any bug or not. Now, people started asking whether this software will work when I give some data to it. Now that becomes a big question, and people did not have any answer for that for quite some time, because we used to consider software as a service, and it took a couple of decades for people to understand that software also is a product which is made by human beings. That is another peculiarity of the software. Hardwares in many cases we make by machines, but software till now it's made by human beings only. And that gives another dimension to the problem. With human beings, it is known that more than 15 lines of codes cannot be written by a human being correctly at a stretch. But we have softwares which goes into lakhs of lines of codes. So obviously there are a lot of problems there. How to find out where is the problem? Because you cannot see it. So that problem has been referred to as a software reliability problem. So the first thing we have to understand, where is the uncertainty in software? Because if I give a data to a particular software and if it fails, whenever I use that data for the same software, it will fail, irrespective of what is the time lapse in between. Unlike hardware. Hardware has a fatigue, has lots of other problems, but software doesn't have those kind of things. So software, if it is kept properly, then the same data which gives me a good result, even after 6 years, if I use the same data for the same software, it will give the same result. And that's the beautiful quality of software. So hence people started thinking that where is the uncertainty there? Because if a data gives the right answer, every time I use it, there's no uncertainty. Similarly, if data does not give me the right answer, then every time the same data I feed in, it will give the wrong answer. So where is the uncertainty? So that took quite some time, and the first paper on research paper on software reliability came in around 1972. And that was a beautiful paper by Jelinski and Miranda. It is more known as the JM model. And it is very easy to understand. Of course, when we develop a mathematical model, we have to use a lot of assumptions. So a lot of assumptions were there, and that there the journey started with software reliability. People understood that software quality also is very important. We have seen in 90s the Gulf War, and in Gulf War we have seen a Patriot missile which is made by US was thrown to connect the Scud missile which is made by Russia. And because of a software fault inside the missile could not connect the Scud missile. So as a result, the Scud missile went and killed a lot of American soldiers. So all this have started happening, and people started talking about that software quality needs to be understood properly and how to measure that. So there are different software quality aspects. One is whether I can make the modules usable for some other software as well. So there are various kinds of quality aspects, 8 aspects are there. One is, does it do what I want? So which is known as the software reliability. Does it do efficiently in terms of time and space, which is known as efficiency? Is it easy to use? And that's also very important, because software, if it is not usable, then it's of no use. Is it secure enough? Can I put it on other machines? So which is known as portability. Can I reuse parts? It's called reusability. Then similar thing, we have maintainability, we have interoperability. But however good with respect to other aspects, if the software is not reliable, then it's of no use. So hence software reliability need to be studied. And because of the examples that I have already given, that people started thinking about that how do we measure the reliability of software. We know from hardware reliability part that to measure reliability of any device, we need to have some failures. Without failures, reliability cannot be measured. So software, when a particular software is tested, some failures are observed. So based on that data, whether we can predict what is going to be the reliability of software. So this is the whole subject called software reliability. Now, There are various uses. As I said, that most of the sophisticated devices will have software as well as hardware. A very recent problem that we faced with Indian Space Research Organization, or ISRO, where we know that what ISRO does is what we see on TV is they are launching satellites. So we see the rocket which is taking all those things going up. That actually is the first phase rocket. Now, after it lifts off, it goes to some distance, then it ignites the second phase rocket, which again takes it to further distance, and then that ignites the third phase rocket, inside which the satellites are there. So the job, there is a software inside the third phase rocket, which actually guides the hardwares so that the satellites are placed in the right orbit. You cannot just throw it anywhere. So it has to be placed in the right orbit. So the whole thing is done by a software. And we know that next year possibly ISRO is going to send man to space. So they have already got the reliability of hardwares, but somehow they were not able to find out how to go through about the software part. So that is where they found out from Trivandrum, they found out that in ISI probably we can do something. And we just asked them that we can't see that software whether it's working or not from here because it's in space. Okay. So what is the data that you have? So they said we simulate the whole condition on the ground and we give a lot of inputs to our softwares, and based on that we sometimes get some failures. So whenever we get some failures, we find out where is the error, and then we correct those errors, and that's how it's going on. So we said, fine, can you give us that data? So they gave us that data, and based on that, our job was to find out what is the reliability of software. Means, what is the probability that it will work when it is required. So based on this data, we developed a model which gives us a reliability estimate, a very, very good estimate. I won't exactly tell you the figure, but they said that they have several successful missions. So obviously reliability has to be 1. So I said, you can't just say 1, because reliability 1 means you don't have anything else to do. And then where is the need of data then? So we have developed a model based on the failure data of their software, launch software. And then based on that, the reliability turned out to be very good. Now, these are called critical softwares. Another related problem that comes with software is no software is released before testing. So when we do testing, we try to find out the bugs in the software and correct it. Now, the moment we correct the bugs, the software reliability improves. So the question is, how long shall I keep on testing? Because nobody knows how many bugs are there. So that becomes a big problem. That's a big area of research by itself. And we have done some models on that as well. The optimization here is based on several criteria. One of the criteria normally the commercial software developers put is the cost. So they give a budget for development and testing of software, and once the budget is overrun, they are supposed to stop. So that is one way of doing it. The other way is, say for example, one can see that because we are trying to find out as many bugs as possible before it is released, so getting a bug can be given as a sort of award. So if the testing group finds out a bug, suppose we give an award to that group, and so obviously they are supposed to maximize that award. So based on that award, there are some models which maximizes that award as well. The third one could be particularly for critical softwares like the softwares used by ISRO. You have to achieve at least some amount of reliability, otherwise it cannot be used. So that could be another constraint based on which a lot of models have been developed. And there could be combinations of all these three different kinds of constraints. So that is one part of it. The second part is actually based on the failure data, how to estimate the reliability of software. So our recent work, we have used a very nice concept, probably for the first time in the world, is the size of a bug. So we know all bugs are not same, because some bugs will have more impact compared to the others. So can we think of a size of a bug, and then based on that, we have developed the model, assuming that bigger size bugs will be captured first, and those who will remain will be of smaller sizes. So with this basic assumption, Professor C.R. Rao actually had done similar work long back. But for software reliability, we have used this concept recently and got a good estimate of the reliability of software.
We are immensely grateful to Dr. Chakraborty for his excellent deliberations.